Hello, so we're back, and this time we have a MacBook to fix. This job came from a local repair shop, and the problem is water damage. Yeah, so this is a nice MacBook 2020. We can see the screen is cracked here, but this can be replaced. So hopefully the screen is good. So the MacBook is dead. I understood it's like full of liquid damage. Let's open this quickly and have a look inside. Okay, this is looking bad. I mean, check here. Wow. Sweet liquid. Uh, This is like a nightmare. Look what is here. That sucks. You know what I mean? Yeah, you can take the board out, clean it. But here, everything is with Coca-Cola. Oh, this is crazy. Okay, let me disconnect the battery. Let me take the battery out. This it will be an insane job. But it is what it is, yeah? Wait, where is this screw? Someone took the screw out. Lol, so I'm suppose I'm not the first one. Where is that screw? Oh, that's crazy. Okay, so we took the board out, and you know what? It is looking a little bit bad on the back of the board. But you know what? I believe we can do it. So the charging port is clean, which give me hope for this board. Huh? What do you think? Of course, we cannot clean something like that with a toothbrush, yeah? So we need some pro tool. This is a MacBook, it's an expensive one. The repair is expensive, yeah? So we're gonna use some special tools today. So the liquid damage didn't come from the keyboard, yeah? So it came from the back or from the sides. Good. Let's leave this on one side and let's focus onto the motherboard. Yeah? Let me bring the ultrasonic cleaning machine. Okay, good. Yeah. So the ultrasonic cleaning machine is here. Inside we have a special solution, H2O, warm, around 40, 50 degrees. So what we're gonna do, we're gonna stick this board inside. Yeah? Good. Perfect. Perfect. Now in order to make this ultrasonic procedure to work, yeah, you have to apply some vibration, usually around 30 kilohertz. Yeah, that means you have to move the hand around 30,000 times per second. Yeah, you move it quick, and the board get clean. I mean, at my age, I can do probably like 2 hertz, but yeah, that's all. I'm just joking, you know. Yeah, it's Coca-Cola. We are cleaning with water. Yeah, we are cleaning with water this board. What can go wrong with electronic motherboard and water? Yeah, I said it many times. They are going hand in hand. So here was some liquid damage, clean. Okay. You won't believe how expensive are the MacBook parts. So this chip probably around 25 pounds. This chip is around 30 pounds. Just to understand how expensive they are. Yeah, I do have them, but yeah. Do you think the water goes under this shield? The Coca-Cola, sorry, because this is Coca-Cola damage. No, this looks perfectly clean, huh? Perfect, let's dry the board. Fantastic, so the board is dry, let's go under the microscope, but please admit it, this board looks like new. You won't believe this board was liquid damage, huh? Let's go under the microscope and actually find some damage there. So can we spot any damage? Let's see if we can spot. I can see something there. It's no point taking this shield out because the liquid didn't go there. Yeah, that's fine. Yeah, all looks good in this side of the board. On this side of the board, I'm concerned about my CD chips, but they look good. That fuse is blow up. Let's check the fuses. Do we have a blow up fuse there or what? So this fuse is good. This fuse is good. There I can see some marks of liquid damage. Here, this capacitor looks completely dodgy. Let's check that capacitor. But you know what? This capacitor is good. I mean, it's good. Yeah, looks good. 45 ohms. Not sure about that. Those capacitor looks dodgy. 45 ohms. I mean, why I have 45 ohms everywhere? Those are 45 ohms, those have 45 ohms. I'm happy this chip is doing fine. You know, which is doing the main power rail. Yeah, we didn't took this connector out, but there's no point. We have a fuse here, look here. Yeah, that fuse is good. This fuse is good. I mean, I'm sorry, but I can't see why this motherboard won't work. Do you see any reason why this motherboard should not work? Let's bring the laptop back. Good. Let's plug a USB. Let's plug a USB-C. It's coming on. And I have 5 volts. Lol. No, it's not working. That sucks. Five volts. No, my connector is clean, you know what? My connector is fine. It's no problem with the connector. Okay, why is not working? That's a very good question, yeah? Let's take the port out and try to diagnose and repair this board. Let's check the main power rail if it's shorted. So the main power rail, 27 ohms. I don't think it's right 27 ohms. Huh? But the main power rail, 27 ohms, doesn't look good. Those capacitors are suspected. Okay, so we have the board and the charging port. Let's connect the charger. Good. Now let's check the voltage. Yeah, same 5 volts on those capacitors. Here we have 0, here we have 0. And this capacitor, 0.2. Okay, the main power rail is 0.2, so we should have at least 5 volts here. So in this moment, we are paying attention to this chip. Clearly, we have voltage here. Yeah, we have 5 and 5. So if the main power rail is missing, okay, you won't have voltage here on the 3.3 volts power supplies and the EC chip. So how we can check that? Yeah, we have to concentrate our attention here on this little prick, expensive prick. Let's see what we have here. We have 5 volts. So this has voltage. 5 volts. 5. Not sure about 1.1, but we can check something else. Yeah. Let's check this power supply. I believe here has to be like 5 volts, but let's see. So here we have. Why we have no voltage on this power supply? Huh? We have nothing, 0 volts. If I remember, here has to be the 5 volts one. You know what? I think we should grab a schematic. PP5E-S2. Wow. Okay, this one, we have to find it. LC320. LC320. And it's this one, okay. Now, this is taking voltage from PP bus 5ES2. PP bus AON. Oh, got it. Okay, so if this little prick, where is that little prick? This one. If this one is not working, we don't have 5 volts. U5200. U5200. Yeah. This prick. So the output, yeah, of course, yeah. AON. You see, after the fuse is PP bus AON. Okay, so this is not present. And I know it's not present because I checked, yeah? So why it's not present? Because the input, we have 5 volts on this chip. I don't know, but let's see if that power rail is shorted. Because if that power rail is shorted, let's lower the voltage, let's lower the current and see on that fuse. So on that fuse we have, so here is taking nothing. Let's raise the voltage. Yeah, start taking some power, right? 200 milliamps. Wow. What is taking 200 milliamps on this power rail? Let me grab the thermal camera. Okay, fantastic. And with the thermal camera, let's see. 200 milliamps. Lol, what is there? What is that? What is that thing there? Huh? What is that one? This chip. Speaker. Speaker amplifier. Why my speaker amplifier is getting hot? So basically it's that one. Check that. Why am I now it's taking only 30 milliamps, but still it's getting hot, and that's not good. Why my speaker amplifier is getting hot? Anyone knows? And you'll think, okay, sorry, because the liquid damage. No, here was no liquid damage. You can see any liquid? Yeah, maybe on the capacitors. It's a little bit of liquid damage. It's not that much. It was on those capacitors. 150 ohms. Yeah, those are looking good. So why the chip is getting hot? Why the chip is getting hot? The output, let's check the output of the audio amplifier. The output is good, and here it's 140 ohms, and here is nothing, right? Yeah, that's normal. So those audio amplifier are bridge configuration. So the output have nothing to do with the ground, yeah? So it's coming from, let's say, like a switching power supply, and it's like you have two switching power supplies with the coils on the middle. Yeah, something like that. So this is a bridge configuration, yeah? So that's not normal to have 140 ohms here. Here is fine. You see, you can compare with this one. You see, you can compare it with this one. So here it's infinite resistance, here it's infinite resistance. So I will say, let's try first, yeah? Let's try just to reflow the chip. You know, maybe has something behind. I don't know. You know what I mean? Let's just give a short reflow. Okay, so we give to this chip a short reflow. Good, let's check the output. So the output has, so I have 57 ohms, 57, 57, and 57. Okay, that seems right because the board is hot. So obviously when the board is hot, the components, it will change their, you know, whatever they're doing, yeah, the internal resistance, like on this case, yeah, 47, 0, 0, 0. Okay, so you agree with me, I give a chance to this chip, but it's nothing what I can do. This chip is gone. I believe the customer has to be, you know, happy with one speaker only. I mean, I try hard. I try hard to make it right, and it didn't work. You seen that, yeah? Okay, now it's fine. Don't tell me it wasn't the chip, so actually it was some capacitor. Let's check now. No, it was the chip, so now it's fine, you can see. Now it's okay. Good. One more time, let's see what is getting hot on the main power rail. Let me be sure I can cool down the other chip. If the chip is hot and you come with voltage, the chip it will get shorted. Okay, that's fine. So one more time. And it's taking nothing. Check here, nothing. No current at all. Nothing. Okay, let's check with the charger. Maybe it will work. With the charger, it's working. We have 19 volts. You can believe that? I can't believe. We have 19 volts. So that means it's negotiating the voltage. The main power rail is present. Everything is fine. Yeah. If the board is still not coming on, let's check the main power rail. Let's see. Let's see the main power rail if it's present. It is 12 volts. You can see on the screen 12 volts. So the main power rail, it is present. The board is coming on. Look, check that. The board is coming on. You can see. Check that. 100 milliamps and has to go up. 200. 300 milliamps. This board is coming on. This board is coming on. What you can do with the speakers, that's very simple. Like on the old time, like 30 years ago, you have a stereo amplifier, one left or right, got burned. You put the speakers on the parallel and you have sound on all speakers. And you have double power. You see, when you put the speakers on the parallel, the output power get doubled. If you put them on the serial mode, the output power get halved. Yeah, so you see? Actually, this is an improvement, Parallel speakers, double output power. I'm just joking. Obviously, I'm just joking. The times are not like then, when you could not find like a chip to buy. Okay, let's test it. Let's see what it's doing. Let's see. Cleaning is no issue. We can clean it after. But before we're cleaning, we have to be sure, we can fix it. Yeah, so I'm not gonna clean before I know, it's fixed. Okay, let's see. We plug the charger. $200, $300, $400 milliamps. We have picture. We have picture. That's crazy. I can't believe actually it's working. Wow. Yeah, we don't have plugs, the connectors and things. So that can be a reason why it's slow. We don't even have the keyboard plugged in. Or maybe we have some liquid damage on the touchpad. Let's see if it's coming on. You can check the touchpad if it's working. But it's unbelievable. So actually the only problem, it was the audio IC. Huh? The touchpad, it is working. Okay, so yeah, it's fine. It's fine. Yeah, I have to edit the video now to hide the name. Wow. Can't believe. Actually, it's working. LOL. I mean, I never found this kind of fault like audio IC. I mean, that's cheap. It didn't had liquid damage on it. Nothing. How that chip died? Huh? Interesting. Okay. So I'll stop now. If you have this problem now, you see a few things we can check. Thermal camera can be helpful, can be helpful. But yeah, I'm impressed. Nothing damaged. I mean, so much Coca-Cola and nothing damaged. Apart from the audio chip, audio amplifier. Actually, it's amplifier, audio amplifier. Okay, so I'll say thank you for watching. Like and subscribe if you like the video, like always. And yeah, you're right. Now the hard work coming. Just cleaning every bit. And you can't just throw it in the water. You have to clean a particular every spot. Thank you for watching. Like and subscribe if you like the video, and see you on the next one. Bye.